Good morning, everyone. Today is Wednesday, November the 17th. We have our Unit 4 review today, which means you're going to have your test tomorrow on Thursday, and then for part one, and then part two will be on Friday. All right. And then the following week before Thanksgiving, we will start the final review. Believe it or not, we are almost there. Yeah. So Noah, so I did send it out to everyone, and Noah says the review was actually pretty fun to do. It wasn't bad, was it, Noah? Everything was. I would say probably Unit 4 test is probably the easiest test of the semester, um, and everything is kind of really straightforward. And in a way, some problems are kind of too easy, in my opinion. But I didn't write the test. Maybe that's a good thing. Yeah, it's not too bad. Now Unit 4 is going to be, well, near impossible if you don't know how to do logs, of course. Like everything we've learned up until now is like we learned how to do new math basically with logs and natural logs. So the test is super easy if you understand the properties of logs and how to solve an equation. It's going to be impossible if you don't understand any of that. But anyway, let's get into it. Okay, log properties expand and contract. So all of these problems, we need to expand them. Contract, you just have to go the other direction. But I believe on your test, they just want you to expand them. All right, so using our log properties. All right, what do we do here? Yeah, move the 3 in front. And guys, we unfortunately don't have enough time to kind of give you several minutes per slide to work on these problems. That's why I sent it out yesterday to hopefully some of you are able to get maybe half of it done, which would save time. But yeah, we got about 15 questions to get through, and then plus the TGA. So keep that in mind when we have time here. All right, yeah, we move the 3 in front, and then what happens? Yeah, it becomes addition because that's the log of the quantity x times y. So it expands to become addition. Now, when you expand it, so maybe on your paper, what do we got to put? Yeah, we got to put parentheses. Yeah, Noah's right. We got to put parentheses. When you expand it to be the log of the first one plus log of the second one, the factors, we need it in parentheses because we're doing 3 times the entire thing. And if you forget the parentheses, you are just doing the 3 times, well, the first one, which is not true. So make sure you have parentheses, and I believe you can stop right here. You don't have to distribute this 3. Just leave it in this expanded form. So you would stop right there. Okay, the second one. What do we do first? Yeah, we want to make it to a power. And because this is the 5th root, we make it to the 1/5 power. Yeah. And we all kind of remember how to do that. Then what? Yeah, move the exponent in front. It almost feels like we know what we're doing here. One more thing. I forgot. Yes, we can move it in front. So let me talk about. We have choices. So we could move it in front in this step, or we can deal with the fact that the A and the B have the 4th power, and we can pull out a 4 in front and then deal with that. Let's say this A had a 3rd power and this B had a 4th power. So let's say it was A cubed and B to the 4th. What would I be able to pull out um, in front of there? You know, pretty much nothing actually. Because remember, it's you when you pull it out, you're basically dividing the exponent, and when you bring it back in, power to a power, you multiply. So 4 times 1 is 4, 4 times 1 is 4. So if that was a 3 and that was a 4, we actually couldn't pull anything out because um, there's no common factors, if that makes sense. I know. It was a trick question. No, I'm sorry. Now, if that was a squared and that was b to the fourth, then we could pull out a 2 because 2 goes into a 2 and 2 goes into a 4. Just want to point that out. But I went ahead and I dealt with this. I factored out the exponent of 4 in front before moving this in front. But again, we could have done it in 2 separate steps. So we have 4 times the 1/5 is, well, 4/5, and then we move it in front. And then what? Are we done? What's probably our last thing? Addition. Yep. And same thing. Don't forget the parentheses around it. But yeah, just make sure you get a problem like this that you factor out the exponent like I did here. And then to double check, 4 times 1 gives us back to the 4 exponent, and then 4 times this 1 exponent gives us back to the 4 exponent. Always double check once you pull it out that it works the other direction. Okay, what do we do here? Yeah, it becomes subtraction. Natural log of the top stuff minus natural log of the bottom stuff. Now what? Yep, exponent gets moved in front. And then, yep, natural log E is 1. And we're done. So natural log E is 1. We should all know that by today. And 1 times that -3 is still -3. So that is it. That's all we can do. Just take note, like if you're given a problem like this and it's said to, well, contract to go the other direction, we would have to kind of like we learned, maybe it was yesterday, we talked about how we can stick on, -3 times 1 is still -3. And we want it to be natural log. So that's why it's natural log E we would stick on at the end. And then this 3 would move to here. Don't take the negative with it. If you notice, like if we're going this direction, the 3 moves back to the exponent, and then subtraction becomes division. So make sure you can go both ways. That's all I'm saying. And same thing for these. Make sure you go both ways. Okay, freebie. This is a freebie problem, in my opinion. All right, you're given a table of values, and um, we need to graph these. So we have, this is x comma y, x comma y. So let me just show you this graph. So just confirm my points that I have on the screen are in fact what is shown in that table. Just double check with yourself to make sure you understand, for whatever reason, um, x comma y, people still mess up graphing coordinates. All right, now how do we graph the inverse of these points? What do we do? We just switch, or we flip x and y coordinates. So x becomes y, y becomes x. You all remember how to, well, the ones that responded at least remember how to do this. Hopefully everyone does. And then we just Do we do anything else after we switch x and y? Do we have to do anything else to these points? Yep, we sure don't. Yeah, if you're given a coordinate and to find the inverse, you just switch x and y and just regraph it. So on this next page, I just replotted. I don't know why I covered that up. I replotted the inverse. So my blue points, those are the points, the inverse. So here's the original. Here's the inverse. Really that easy. It's a freebie, in my opinion. If you understand that inverse of points, you just switch x and y, just regraph. That's it, and it's easy. All right. No, so remember this is a table of values. It doesn't give us an equation. At least my example doesn't. This just represents a table of values to be some function. I don't know. Um, Now, if we knew it was an equation or a function, then yes, I would do like I would do something like this, right? If I knew it was actually an equation, not just coordinates. Oops. Then this previous one would be mm, something like that. I don't know. I don't know if that's even right. Yeah, it looks right. But yeah, you'll see on your test. It's pretty straightforward. All right, solve the exponential equation. I'll give you a moment to get started on this one. I'm actually going to open up the test and just double check that graphing one. All right, to answer your question about do we have to, I guess, connect the points, the answer is yes. However, that question is multiple choice, so you can't really mess it up. All right, for this one, what did you do first? What's the first step? Turn the square root of 5 into 5 to the 1/2 power. Yes, we could do that. Then what? Change 1/5 to 5 to the negative 1. Yes, we also do that too. Else. And we can also divide both sides by 5. Correct. Yeah, I did all 3 of those things in one step. So we divided both sides by 5. We changed the radical 5 into 5 to the 1/2 power. And then we changed that 1/5 to 5 to the negative 1 power. Now, okay, so I did it 2 ways. The way on the left, I do it without dividing by 5, and I'll show that way after Noah. So you wouldn't be wrong if you didn't. But let's continue it this way. All right, what's next? So the exponents in the parentheses get multiplied by the ones outside. Correct. So we have so that we basically pull out that 1/2 to do 1/2 times the binomial x plus 2. Um, I do rewrite it first as that just to make it a little easier to see or understand, and then we multiply it. Okay, then what? Now we solve for the exponent. So yeah, the bases are the same. There is no reason to use log or natural log to solve this. We could, we don't have to. You're creating more work for yourself. But yeah, remember when the bases match, you just set the exponents equal to each other. And then from here, I trust everyone knows how to solve a multi-step equation from like 8th grade. So we add 4x to both sides and subtract 1 both sides. I did that in the same step. So 1/2 x plus 4x is 9/2 x. And then obviously we move the 1 to the other side to get -1. And then multiply both sides by 2/9 to get x by itself. And then that's how we get -2/9 as the answer. No, did you get the same answer doing it your way without dividing by 5? All right, let me just quickly run through that work. And maybe it'll be similar. So still similar stuff. We changed the 1/2 power, the -1 power. 5 is still there. Multiply those exponents together to make it a single exponent, basically. So the 1/2 times the x plus 2. All right. And then I rewrote it just so it looks a little easier to understand. We have, remember, that's 5 times 5 to that power equals 5 times 5 to the other power. Well, remember, any number that doesn't have an exponent, it's always a 1. So that's why I wrote it there. And remember, when you have same bases, what do you do to the exponents? So when we have same bases and you're multiplying, same bases, what do you do to the exponents? Yeah, we add them. So we're going to have 1 plus 1/2 x plus 1. So you combine like terms, that's how it's 1/2 x plus 2. Same thing for the stuff on the right of the equal sign. We have 1 plus -4x just becomes -4x plus 1. And then from here, we have same bases, so we just set the exponents equal to each other. And just like on the right, we solve it. Same answer. No, is that how you did it? Send me your work on Skype, and I'll look at it after class, because you may have accidentally got the right answer by doing wrong math. And I just want to make sure that your operations are actually valid and not accidentally just made some oopses that got you to the right answer. And that does happen sometimes. Another one. Identify the correct graph. Be a moment to look at this. Yeah, this one's also multiple choice. I don't know. It's kind of an easy test. I really think it is. All right. Talk to me about the shifting. What is the vertical or the horizontal and vertical shifting? Down 3 and left 1. Yep, that would be correct. Yeah, we're going. Oops, my pointer. Because of this is your vertical shift. So it's down 3, and then because of this, remember it's always opposite what you see here. So it's left 1. And this is the original. I have this just to show this is the parent function with no shifting. And we can see that y equals natural log x, just like any log, crosses at 1 comma 0. So we look at this point and we just say, all right, from here, we're just going to go left 1 and then down 3 units. Which one of these has shifted left 1 and down 3? Yeah, only C. Yeah, only C. It crosses at 0 comma negative 3. That is the only one that actually has the correct shift. So again, we start here, we go left 1 and down 3, and that ends us at 0 comma negative 3. The other graphs do not hit that point. So this one's pretty obvious if you understand your shifting rules and the parent function. So yeah, C is correct. When in doubt, just type it in Desmos. Okay, this one says, what is the value of the log expression? So it wants you to simplify. All right, everyone quickly do this, and then when you have an answer, put it in chat, please. Sorry, there's not enough time to wait for everybody. -2. Question, did anybody just type it in their calculator and just hit enter? Let me do that. So everyone here did it by hand. So you did so you did the change of base rule. Nobody typed it in and hit enter? You could have. It would have worked for this one. Well, just so you know, if you get a problem like this and it wants you to find the value of this expression, you can type it in and hit enter. It'll give you the answer. So log 1/25 divided by log 5. And did you type that in? Yep, and that works. That works. If you have like a Casio FX 300 or 115, you can actually just type it in directly. It has a key just for that. Oh, you can't. What calculator do you have, Rachel? It does do that. No, I'm using that same exact calculator, Rachel. Turn on your calculator, clear the screen. Let me tell you where that key is. You're gonna laugh when I tell you where that key is. If you put your finger on the on button and then go one key down and press that button. It was like right in front of your eyes, right? It was just right there, right? Mind blown right now. It's been there the whole time. Yes. Yeah, it has its own dedicated key right below the on button. I know. There's so many buttons on this thing. I know. All right. So let me show you how to do this problem without actually typing anything in, because really this problem was intended that way. Whether you decide to go that route is entirely up to you. It is your test, and I don't. It doesn't ask for the steps, which is, I guess, a good thing for this problem. But we can rewrite 1/25 as what? 1/25 becomes 5 to the -2 power. So I do it in 2 steps. I write it as 1/5 squared, and then I write it as 5 to the -2 power. So I did it in 2 steps. If you want to do it in 1, you can. And then you can pretty much see where we're going with this, right? We're going to bring the exponent down in front because it's one of our log properties that we all know oh so well by now. And then what does log base 5 of 5 become without even typing it in? Because we also know this property, which is 1. And 1 times -2, well, is, well, -2. So that's how this problem was intended to be done, was by hand. But of course, we can type it in to verify we are correct. You all should know how to do this by hand, whether or not you do it this way or type it in, okay? Okay, another freebie. What is the equation of the asymptote in the graph of the exponential function? So think back, this is probably the very first lesson of Unit 4. We talked about the asymptote and the equation of all parent functions of exponential functions. So what is the asymptote equation? Y equals 4. Yeah, remember the parent function of an exponential growth problem is always y equals 0, and that y equals 0 only gets changed by your vertical shift. Yep, that is a freebie. Nobody should miss this problem. Nobody. Yeah, there's a few freebies. This is definitely one of them. Especially if you listen to this review, guys. Believe it or not, people actually, because you need the password to open up the test. Believe it or not, people open up this review session and just skip to the end for the password and try to do the test. Blows my mind. I guess they don't want to be prepared. Oh yeah, they're hurting themselves. Absolutely. Absolutely. And people who miss this problem, I'm going to check. Those people that missed this problem are the ones that did just that. More than likely. Okay, so we got to solve this log equation. What do we do? So you want to minus, okay, yeah, we could do it that way. We could subtract natural log 36 both sides. And then if you did it that way, Noah, what would you do? I'm going to choose not to do it that way, but we could. Yeah, so no, I'm going to guess that you already finished this problem because you got it yesterday. Let's compare. So yeah, I went ahead and I just made them to become multiplication because I just didn't feel like dealing with fractions. I thought they're hard or anything. I just thought this might be easier. So now we have this. And now what do we do? Now we can distribute. What else? I guess we can do two things in one. We can remove the natural log. Yeah, we just set the, because we have natural log of stuff equals natural log of stuff. We can just set the stuff equal to each other. It's what we've been doing the last, well, yesterday, I think, right? Well, actually, I went ahead and distributed it before doing that. Huh. And then rather than jump right to the stuff equals the stuff, I did show this step You really don't have to. We didn't show this step yesterday, but I just want to show mathematically when you base E both sides, the E, ln cancel out, and then that stuff just carries down. So I'm just showing you the mathematical thing that's going on, but you can skip that step. And then, of course, solving it should be pretty straightforward from there. Back 288, then divide by 36. No, what happened? Did you find your mistake? What happened? By the way, on your test, every problem that you solve for something like this, don't just assume you're correct. Take the extra 30 seconds or a minute and plug this back into X and check it. Make sure the left side equals the right side. So we would type in natural log 2, hit enter, and then we'll get some decimal and write down that decimal on your paper. Then type in natural log 36 in parentheses plus natural log negative 143 over 18 plus 8 in parentheses, hit enter, and make sure that decimal matches the one you just wrote down. And if it does, the answer is correct. Yeah, always check your answers. Oh, yeah, 2 over 36. Yeah, it's 1 over 18. Yeah, I always verify. So once I have an answer, I always check my answer whether I graph it or I plug it in. I try to do something to verify what I have is correct. And sometimes you got to be creative with that. Yeah, there's no reason you can't check your answers for most of these. Simplify. Again, I think these are kind of simple and freebies. All right, what would we do to this to simplify it rather than type it in? So we probably could type it in. Let's do it by hand. Move the 2 to the exponent. Yeah, so this is 3 raised to this power. So this is 2 log base 3 of 6. So yeah, we would move this 2 to the exponent. Perfect. All right, then what? And it's kind of easy. Yeah, the 3 raised to the log base 3, that cancels out. I'm going to use my pen to show that. So this cancels out, and then that 6 squared carries down by itself. And then, of course, we know 6 squared is 36. And you could also even type this in. So if you have an awesome Casio that I actually love, um, you can type this in and hit enter, and it'll give you 36 just to verify. So I think it's nice to do it by hand first, get this answer, and then go back and just type this in your calculator and see if you get the same answer. Do it 2 ways. Redundancy. And you realize that you have the right buttons. That's right. That's right. I would say a lot of models can actually do that, not just the Casio. Like if you have a TI scientific calculator, you can probably do it too. You just haven't figured it out yet. And you haven't asked me, or you haven't looked it up yourself. Either way. That's funny. The more we know. Okay, inverse. We have f of x equals the cube root of that stuff minus 3. How do we find the inverse of this equation? Switch x and y and then resolve. Yeah, that's exactly how we do it. Well, first I rewrite it with y equals instead of f of x, and then I switch x and y, but we can do it in the same step. All right. We're gonna add 3 to both sides first. Does that sound like a plan? Yep, add 3. Then we're gonna cube both sides. Now, do we cube the x and the 3 separately on the left? Yeah, no way. That's an illegal math operation. When you cube the left side, you must cube the entire quantity. Can we distribute that 3 to both terms? Yeah, absolutely not. No, we are definitely not allowed to do that. That's a common mistake. We cannot distribute a power to multiple terms. That is illegal math operation. When something has, like a binomial has a power of, in this case, 3, it means multiply by itself 3 times. So I would have to write x plus 3 times x plus 3 times x plus 3. And that's a lot of foiling we would have to do. Yep. So don't make that mistake. Do not distribute to terms. Not allowed. It's a common math rule that is broken. All right, and then we just subtract 3 both sides, and then we're done, right? And then rewrite it with the fancy inverse notation, f of -1 of x equals, well, the answer, x plus 3 quantity cubed minus 3. And again, how can we verify that this inverse is probably correct? What can we do? Yes, you would graph both functions on the same graph, and then you would remember the inverse makes a reflection over what? Yep, over the y equals x line. So that line that goes at an angle. So you visualize folding your paper over that that y equals x line, so corner to corner, top left to bottom right corner, and it should be a reflection over that line. So if you graph both those functions and it looks like they are a mirror image of each other, you probably did it right. Easy way to check it visually. All right, solve the log equation. Whoops, I meant to cover up everything, not just that. All right, nothing to see here. Okay, everyone. What do we do first? Yeah, we're going to base x both sides. We want to, that's kind of weird seeing an exponent as a base. But yeah, we're going to base both sides with an x. To get this, and then from here, we can see that using one of our log properties, this cancels out and the 1/8 carries down. And then what do we do? Yep, we're going to cube root both sides. And don't forget, when you cube root a fraction, you are cube rooting the top and the bottom separately. If you've forgotten, that's what we do when you cube root or root any fraction. You do the numerator and denominator separately. Now, do I need to put a plus or minus? I do not. And the reason why is because the index is odd. If it was even, I would have to. And I said it a few times throughout this unit, I think. Yeah, it's a rule that we learned in a previous math class, like probably your freshman year. I don't want to get into it because it's kind of a long explanation. But long story short, if the index is even, yes, plus or minus. If it's odd, then you don't need it. The cube root of 1 is 1. What's the cube root of 8? Yeah, cube root of 8 is 2. So 1/2 is the answer. All right, more logs. What's another way that we can write natural log 12 divided by natural log 4? By the way, there is an infinite number of possibilities. I don't know how did you expand it? Because no, no, you're mixing up that. So this is natural log of 12 divided by natural log 4. This is now we could let's say it was natural log of 12 over 4. Then yes, we could say the natural log of 12 minus natural log of 4. But do you see how this is not the same? Now, if you expanded the top, we could do like the natural log of 2 squared plus natural log of 3 all over the natural log of 2 squared. But yeah, no, yeah, not the same. Yeah. So what's another way? Give you a hint. Change of base. So think about the change of base. How can I rewrite this? So log base 4 of 12. Yep, that would be correct. That's one way to do it. All right, so that's one of my possible answers. What's another way? Natural log doesn't have a base. So no, natural log 4 doesn't exist. Natural log base of 4 doesn't exist. Remember, natural log is just log base e. Kind of leads to my other way of writing it. Natural log is log base e, so I could rewrite it like that. What's another way? And to help you kind of maybe push you along the way, think about this. How can we rewrite this as something else using change of base to make it look different? Yeah, log 12 over log 4. That would also be correct. Which is common log. I don't know why I put the 10 there. We don't need it. Yeah, there's an infinite way to rewrite this. We could do log base 2 of 12 or log base 2 of 4. Log 12 over log 4, log base e of 12 over log base e of 4, log base 4 of 12. So there's an infinite ways to rewrite the original problem. All right, is this clear? Going over it using change of base and how we can rewrite it. Now, if you typed in all of these, you type this in, you type this in, type this in, type this in, hit enter, you would get the same answer every single time. When in doubt, just type it in. How would they write it on the test? Let me take a look. I don't know. I forget. What number is this? Any idea? Oh, you're gonna have a bunch of choices, and they want you to select all the correct answers. So it's like click boxes. You'll be given 1, 2, 3, 4, 5, 6 choices, and you select all the ones that are valid ways to rewrite it. By the way, I'm actually really glad you made that mistake. Um, so this right here, when you thought this becomes subtraction and it's not because it's not this. Let's say the question on the test was this. They're going to have this as one of the possible answers, and it's wrong, obviously, because we already went over it, but hopefully nobody makes that mistake. Yeah, this is no. Yeah, that's not an answer. It will be a choice on your test. I saw. Yeah. So hopefully people watch this recording. Hopefully for the review. Hopefully the 1030 class mentions this as a possible answer, so I can go over it. Because if they don't mention this, I'm not going to cover it in the 1030 class. I can't give everything away. All right. This one. Exponential to log form. You have a choice. You can use the conversion formula, which I don't like nor have memorized, or we can just do the math to convert it into log form. So what do we do to convert that? Yep, log both sides. Um, well, we would probably want to log base for both sides. It'll save us an extra step. Then the x moves in front. Log base 404 becomes 1, and then you have your answer. That is the easiest way to do the problem. On your test, they may have it written just backwards like this, which is obviously the same answer. I think this way, if you use the formula, just because that's how they have it in the formula, backwards like this, same thing though. Now, if you off to the side, if you decided to log both sides without doing log base 4, we would have basically x log 4 equals log 7, correct? And then we would have to divide both sides by log base 4. So let me, so we divide both sides by log, sorry, not log base 4. We divide both sides by log 4. We would get x equals log 7 divided by log 4. And by the way, if I don't write the base, like I'm not doing now, what is the invisible base actually? It's a 10. I just want to make sure we all know that. This is called common log. Yeah, it's a 10. Now, once I have it in this form, we have one more step to do. Write it as a single log. How do I do that? Yeah, we use the change of base formula, and we just go backwards with it. So we have x equals log base, that bottom number, which is a 4, and 7, which is the same thing as the original answer, right? So we just had we had an extra 2 steps. We had to divide both sides by log 4 and then do change of base to get to this. Now you can avoid these 2 extra steps if we just went ahead and log base 4 both sides at the start. It just saves 2 steps. And it probably seems easier too. Either way though. Okay, and that was it. That was it for your test. I think it's really straightforward. It's very straightforward. In my opinion, probably the easiest test of the semester. As long as everyone has learned how to do the log properties and solve log equations, this is really easy, in my opinion. I do expect high scores on this test for sure. People who wait to the last, it drives me nuts. People who wait till like the week or before everything is due, like the locking date, and they try to get caught up in pre-calc, especially last unit. That was probably a nightmare for people to catch up on. That was like almost 4 weeks of circles and ellipses, hyperbolas, all that fun stuff. Can you imagine doing all of that in a weekend, or in some cases a day? Yeah, they weren't very successful. Yeah, guys. Pre-calc, you need to be more responsible and stay current the best you can. Falling a day or 2 behind, not a big deal. Falling 3 weeks behind, that's a big deal. Yeah, plus when you learn everything in 1 day or 2 days, are you really learning it? Are we? Not really. It's going to go in, it'll stick for a minute, and it's going to go out. Yeah. And again, guys, people who remember, pre-calc is a choice. If you plan on going to a university right out of high school, you need this class. If you plan on doing something else like trade school, community college, or just working, you don't need this class. I think this is a really fun class, and you can take it for fun if you don't plan on going to a university after high school. But yeah, some people, they just maybe don't realize that, or they don't know that, and if you're suffering through pre-calc and you don't pass it, um, people's habits don't change that easily, and those will carry over when you go into college. And with those habits, you will be less successful. High school is too forgiving sometimes, in my opinion, and some teachers, including myself at times, baby the students too much and don't put enough responsibility on them. Learn slowly, forget slowly. Learn fast, forget fast. Ooh, I like that. Learn slowly, forget slowly. Learn fast, forget fast. I love it. All right, TGA. By the way, I have not uploaded the TGA yet. At least it shouldn't be. I need to change it. This is not going to be the question you get. It might be. I don't know. I need to look at it. But this is just an example of what you're going to see on your TGA. Numbers will likely change. So don't turn in your TGA with these questions. That'd not be good. Okay, this one says Gregory may choose between 2 accounts in which to invest $5,500. Account A offers a 2.33% annual interest rate compounded monthly. Account B offers continuous compound interest. Greg plans to leave his investment untouched. In other words, no further deposits and no further withdrawals for 10 years. Oh, wait, no work, no credit, of course. I have to put this because some people think that it's okay to turn in answers with no work. Part A says, which account will yield the greater balance at the end of 10 years? Part A, you need to tell me, is it account A or is it account B? That's all it's asking. B, this says how much more. Let me underline the word more. Because some people, English is hard sometimes, even for me. More. How much more money does Greg earn by choosing this more profitable account? Let me give you an example. Let's say Rachel makes $20 an hour, and Noah makes $15 an hour. How much more money does Rachel make? $5 more per hour. Yeah, see, English is not that hard. It wants to know more. In the past, people just give me the amount of the bigger account. Well, it wants to know how much more, not how much you're going to have in the end. So again, how much more money does Greg earn by choosing the more profitable account? It's pretty easy, right? You're going to have to look in your notes for your two formulas for money, one for compounded yearly, and the one for compounded is in this case monthly, but it's two different formulas. It's a compound formula, and then the one is a continuous compound formula. So make sure you read it, make sure you do it, make sure you, when you answer part A and part B, make sure you reread the question, the part after you answer it, to ensure that you actually answered it properly. Anyway, should be really straightforward. So part B, so I'm reading a chat question. So part B is in the context of the 10-year period, right? Yes, of course. Yeah. Yeah, it's both accounts. So yeah, when you do the math, they both start at 5,500. It's just after 10 years, you're going to have different amounts based on compounded monthly at 2.33% versus compounded continuously at 2.33%. Yep. All right. Oh, this must be important. When you are finished, please put all your work, images of work, in this or a blank document. Ensure images, work are clear and easy to read. Also make sure that it's rotated properly. I don't want to turn sideways or upside down to read your work. Save the Word document as a PDF file, underline, and upload this single PDF document to be graded. Some people are still uploading like 6 different pictures, and you just throw it in a Word document for me, and 1 picture per page blown up. Make sure it's clear. Make sure the room is well lit before taking a picture of it. And just throw them all in a Word document and save it, and go to File, Save as a PDF, or File, Print, and then print to a PDF. Both do the same thing. You can also download a app on your phone or tablet, like Simple Scan or Tiny Scanner. I don't know. I got a few apps on my phone that do just that. They're free. Take pictures of many pictures and then combine them all into a single PDF. You can do it that way too. But yeah, whatever works for you. Most of you are doing it. Some are not. Oh, I even have the same thing on this next page. Huh. All right, number 2. So given log base 7 of 3 is about this and log base 7 of 16 is about this, evaluate the expressions, no credit. Do not type this in. So this TGA number 2 has 2 questions in it. So you have this one, and you're going to have this one, for example. And you can only use the givens to solve this. You can't just type this in and hit enter and give me an answer. You can't just type this in and give me an answer. You must use these givens. We went over this type of problem during class, so you need to find whatever day that was and check out this. It was the very end of the lesson. I can tell you that. I forget which one though. But if you notice, like we don't have like a log base 7 of 147 up here. Well, we can do some math like we did during class to make one of these probably equal log base 7 of 147, assuming 147 is prime or not. Not difficult problems. This number B will take some steps, and I am looking for very particular ways. And there is at least 2 ways to approach this problem. So A should be really easy, straightforward. B is, well, a little harder. But yeah, anyway. Shouldn't be too bad if you actually went through the modules and worked these problems out in the module, because they were in there. And then obviously in my live session, I went through them with you all. All right, that's number 2. And then number 3. There are 35 bees in the hive when it is first observed on Saturday. After 3 days, there are 42 bees. It is determined that the population of bees increases exponentially. How many bees will there be after 30 days? Express your answer as an exact value and round it to the nearest whole number. Well, it kind of makes sense because we're talking about a living thing, bees. You can't have part of a bee. Either you have it or you don't. But anyway, if you noticed on your part 1 of your test, you didn't have any of these problems. Well, we went over it yesterday. Is that yesterday? Yeah, it was yesterday, right? We did this. So if you are up to date and you understood yesterday, this is a really straightforward question on your TGA. And in fact, you may just want to do this problem before even doing your part 1 of the test, just so it's like fresh in your mind from yesterday. Again, I have to upload it, and I will upload this later today. So I'm going to modify it about noon today, and then I'll have it hopefully done and up by 1 o'clock. I got to make sure that it's correct, because last time I uploaded it, I made some mistakes in what I put it, and I had to re-upload it like 3 times. Hopefully I don't make that mistake this time. But yeah, so that's your 3 TGAs. I think number 3 is really not that bad. If you were here yesterday and you went through all 4 problems together, it seems a lot harder than it really is. Number 2 is probably the hardest question on the TGA, if you think that's hard. This is, I think, probably the easiest one on the TGA. So yeah, there's the 3 TGAs. Kind of straightforward in my opinion. And then the password. So here's the password. The password is EV246810. You know what I should do? I should just like leave this uncovered for a moment and then cover it back up and let the recording run for like 5 more minutes and then stop the recording. Would that drive people nuts when they try to go to the end of the recording and they can't find the password? It might. I don't know. Maybe I'll do that. Everyone got that? EV2468. Hey, that's like even, right? Even 246810. I'm so clever with my passwords. Even 246810. All right, I'm just gonna cover it back up. I still get people emailing me, like last unit, asking me where the password is. I found the test in the course content, but I can't find the password. Yep. Every test that we have, the password is always at the end of my review. We all know that. At least most of us do. All right, well, that's it. I'm gonna just go back to the very beginning of this just for fun. Anyway, guys, well, thanks for coming. As always, I hope you reviewed something today. And message me if you have any questions, during your test, before your test, even after your test. I'd be happy to help you out, preferably by Skype, because that is the fastest way to get a hold of me. I only check my email maybe twice a day, usually at noon, and then maybe before I log off for the day. But Skype, I'm usually pretty good about responding. Pretty good. And the PowerPoint is sent. I emailed everybody. About that one, or are you talking about something else? All right, I'm gonna go and stop this recording. All right, guys, good luck.